this session, we're going to be talking about optimizing pipelines and managing cost. We're also going to be covering billing, cost management, and talking about how to identify areas of your pipeline that would benefit from some optimization.
Okay, so let's talk a little bit about billing. This is kind of the basics. So if you know about it, this might be reinforce some things just to verify it. You're brand new. Hopefully you get to learn something here. So the first thing we're going to start with is just understanding that read connectors and write connectors, no matter what data plane you're on, run on the Ascend control plane, or as some people refer to as Spark. So just to make sure everybody knows that that's kind of the way this is set up. When you get the transforms, that's where the data planes of BigQuery, Databricks, and Snowflake, you take advantage of those platforms to actually process there. But one thing to note, the Ascend data plane can be used for edge cases and transforms as well, but most customers won't do that. So they'll usually use the BigQuery, Databricks, or Snowflake because that's why they have the data plane. But just so you're aware, you can do that. And then when you get to the data feeds, these are just secure pointers for connection purposes. So there's no processing there, no charges or anything around that. Okay. Okay, now we'll get into kind of the basics here. This is really around the Ascend control plane. So if you don't know or you haven't looked, if you go into your Ascend platform, click Observe. If you have access, you'll see billing usage and be able to see some things. And you may ask one of the first questions of why does it show 2 DFCs running every hour? I have nothing running. Well, one of the things as an always on platform and monitoring is we have to have certain nodes up and running. And that is something that we charge as kind of a base platform. I'll have some news on that in a little bit, but essentially note that those 2 DFCs are running every hour at a minimum. If you process something and it's a small job, you might not even see the blip there. If it goes above 2 DFCs and has to scale up more, then you'll see the spike above that when you look at the billing usage. So this is a picture from our platform. As you can see, there's an Observe over here, and then we have the billing, the job usage, timeline, and lineage. So right now we're in the billing. And in this view, I'm only using the Ascend control plane. So as you can see, as I mentioned, you can see these 2 DFCs and you have these little blips. You might actually have some jobs running in here, but it just never scales above that. But you can see I ran some big job that made that spike quite a bit. And you can kind of see that. Going over to the right, just to give you some navigation here, I picked the 7 days, but you can do a custom range or anything that you'd like. DFCs and vCPUs, just, the secret about it is take vCPUs, it's 8 times the DFCs. So if you had something like 10 here, this would show 80 vCPUs are being used, just as a kind of FYI on that. This is a graph. We have a table view, so that's all the values. Based on the dynamics, the time granularity. So I'd see every row in there would be by hour, it would show me a value, and I can export that and use that, and you can actually see both as well. But again, you can do that by day or month or something like that. So that's a few just navigation things about how to see that. Now, this is a little bit of a sneak peek into what the data mesh will look like. Say you're running on BigQuery. One of the things you would see when you go into billing usage today is you'd see BigQuery and you'd see the DFCs. And both of those would be something you could click on to see how many DFCs am I using, how much BigQuery am I using. This actually shows when you get to the data mesh, if you didn't see the presentation yesterday, this is around the ability to put in your credentials and use any one of these data planes all within one environment. So now I can see, I processed, I've decided, you know what, I'm gonna start doing some Snowflake processing and check that out. Let me see what's happening there. You can click over there and look at it and see how many Snowflake credits are being used. Databricks, you'd be looking at DBUs. BigQuery, it'd be terabytes processed. Each one has a little bit different dynamic. Okay. So this is something that is kind of a new announcement for everybody that kind of tuned in here. So one of the things we're looking to do is to do cluster billing. So currently it's based on nodes. And we're looking to bill for clusters, not for nodes. So this is coming. There's a lot of caveats. Communication will be going out. How you get to that, I just want to set the expectation that we're working on this. This is around the theme today about we're listening to our customers and looking to make things, take your feedback and act upon it. What this also does is observability will start to show billing by cluster. We've wanted to put, especially when we went from DFCs and some of our customers are now on credits, we wanted to provide like, how much am I using and what's my balance if I did a commitment? This is kind of along those same themes of making sure that you understand what's there. You can actually see what's being billed in the cluster billing. And the greatest thing is when clusters shut down, there is no billing. So what I showed a few slides ago, where I said 2 DFCs are always running and you're getting charged if nothing's running, when you go to cluster billing, you'll actually get no billing. And I can hear the applause through the line already. So that's something to look forward to. Okay. All right. Anything, Tessa, that you see there that you've had your customers ask about, or anything that maybe the cluster billing, have they mentioned about the 2 DFCs and concerns about that?
Yeah, definitely about the 2 DFCs. What is running here? Yeah, so it's really exciting to hear the change in the cluster billing.
Yeah, we're excited about that. So more to come. Okay, I'm going to jump into cost management. So this is an area that we feel like we have a approach to this. And this is one approach on how you can do cost management. And people can kind of take this and morph it a little bit to what makes sense for you. But there's challenges facing data teams right now, right? The advent of SaaS has spread the perception that raw data processing is free, right? Because I'm just getting the data, I'm just moving it over here and I'm doing a few things to it and it's writing, like, why should I have to pay for that? It's just moving stuff. And companies are challenged by this because if you have a lot of data, a lot of feeds, and you're having to, take things into your system on a regular basis, that's a lot of data processing and that can add up. Budgets are challenged when all they see is one large cost number on an invoice, right? And this is saying, the infrastructure, the processing, and you just say it's X dollars, and you're like, okay, that's just one big number. It's hard to kind of see what's behind that. It's hard to justify. Cost justification falls on the central data team. Like, okay, data team, why are you using so much? It's like, it's just a lot of data, right? So this will help. Most systems don't have a mechanism to break down costs and understand causes. So we'll talk about that. And the cost breakdown by data service can justify costs and provide foundations for chargebacks if you want to do that. So when we talk about this, we're really our viewpoint is start to look at costs by data service. So we'll talk about data service strategies of how you name that and what flows you put in that. But you can categorize those data services as anything. I mean, the easiest thing is departments, because departments usually have budgets, and then you can say that budget's going there if you want to charge it back. But you could do anything. You could pick any type of entity that you want to say a data service is blah, and you have these different workflows and data pipelines running in this data service because I want to see what that cost is. Okay, so the strategy. Most companies, for data services, most companies group it into dev and prod. And they might have like test things or something like that for like individuals and stuff. But that's the only thing they do. Data service construct is important. So this is where it's one of those things that when customers get our product, they just start building things. Oh, I have in data. And they're not thinking about this part of it, about, well, how do I really understand the costs and break that down? That's why these are the type of things, if you joined the keynote at the beginning, when we talk about rapid start, we talk about data service constructs and cost management and why you do these things. And we help build that for you so you have it structured in a way that you can get this if you'd like to get these costs. But to think about that at the beginning. Okay, strategies for workloads on the Ascend control plane. That's a Spark. Leverage the job usage charts. So we'll talk about that, and I'll show this to you. Download the table. So you're going to actually run something based on data services and look at the table, and you can download and export that so you can view that. You view the CPU hours for the calculation of the percentage of usage by a data service. So I can, do a view in job usage for a month. I can look at the table. I can sort by the data service. I can do the calculation of, how many CPU hours it used compared to all the other things and get a percentage. So now I have a percentage per data service. Recommend by month. I wouldn't do this on a daily basis when you do this. Consider if minimum DFCs are split across data services or part of the core data. So you may say, I'm only going to look at the usage, but one of the things that you'll see is the utilization, that we're working to actually have the utilization much higher when we spin things up. Right now, you're going to see, well, that doesn't exactly match the DFCs. And so you have to kind of do this calculation. But the hard part is what happens when there's 3 hours in the day, you have the minimum DFCs running. This is before the cluster billing. You have those two DFCs running for 3 hours. Who pays for that, right? Do you take the percentage of the CPU hours and break it across those groups for that month? Do you just pull those out, which is harder to do, and figure out that's a central cost? These are decisions you'll have to make along that way. But the key is you take the data service percentage and apply the DFC charge. So you're taking percentages of the data services, and then you're taking that percentage that each one did that should equal to 100 if you include all those minimum DFCs when nothing's processing, and then you push it against the charge for that period. Okay. Now I think
wow, Alex, that was really helpful. I never thought of it that way. I like that.
Great. Yeah, and we don't have many customers doing this today. We have customers asking us about it, thinking it's not possible because maybe the tool they came from, it was hard to do that, or they could never do it. They just was one lump cost. And these are things we want to get more education and more knowledge out there to our customers so they can manage this. Because I don't want to be sitting there, justifying what's this X dollar of hundreds of thousands of dollars it costs, and I just like, it's data, right? I mean, that's not a real good response versus saying, well, there's core data services that everyone uses, these 5, and that cost is X. Now, marketing has certain ads and certain pipelines they need out of these specific systems. Now that is going to be this X, right? And then you start to break this out. And if you have 5 or 6 buckets and you have the costs there, you can say, okay, I need to look at the marketing budget because, that looks a little bit higher than I would expect, but let me learn a little bit more. Now you have something to go after because now you have a little bit of a breakout. Again, even if you don't do chargebacks, it helps in the conversation, right?
Yeah, even identifying pipelines that are maybe not even used by departments.
Right. Yeah, absolutely. I mean, that's a nice thing about chargebacks, because then people will go, well, wait a minute, what am I paying for? And then you start to break it down, and they I forgot to pause that pipeline, right? So I need to pause that because we're not using that anymore. Yeah, it does create a different due diligence and maintenance of things to make sure the right things are processing. Okay, so now I'm going to jump into, well, what if I'm on a data plane? So that's the part that, there's a way to do this, right? So in Snowflake, you can create a separate warehouse per data service, right? So now when you get your Snowflake bill, you can actually see the costs there and allocate that to the data service. Databricks has something similar for the Databricks SQL or compute warehouses, and BigQuery you can do it based on projects. So there is a way to get that cost and then add that in there if you have the data plane. So one of the things we're putting in here is Ascend's work on infrastructure costs. So just, we've talked really about the Ascend processing part of it, but there's also infrastructure costs. And we want to let everybody know that we are continually looking at ways to save you on your infrastructure bills. We get nothing out of that other than satisfied customers with lower bills on their infrastructure, but we're trying to do our due diligence on both storage and compute and networking and all those things. So if you missed this because it was just prior to this, make sure you watch that recording, and Joe has a lot of good information to share there. So when you do this cost management, a lot of pros: ability to assess costs for data services, enableability for chargebacks, enableability to manage budgets with justified costs per data service, but you do lose a little bit of the resource sharing. So that's a little bit of a downside, but probably very minor compared to the overall benefits to that. So what are some suggestions? Manage dev carefully. I talked to some customers, their dev costs are higher than their production costs because they have huge data sets or the same data sets. They might have a bunch of people developing in there, and they're instead of going off a small little, they're going against production data and anonymizing it or something like that. So the key here is just manage dev, right? Really understand what that is. And you can do data services there and do the charge back to the groups as well to understand your dev breakup, or maybe, create like 3 clusters and you work in these different areas. You could have a QA and a stage and a dev or something like that, and then you can break out those 3 costs. So think about that. And then clusters will be showing up on job usage is coming. So we want to show that. Okay. So what we have here is observe with the job usage. I've done the 7 days here. I've done just a stacked bar chart. I can see all of this, and you can see down here, I have a graph or a table. You can see as a table, what I've done is I've actually sorted based on the data service. So you can see the grouping. So I can now look at these CPU hours for these 7 days and look at how much that's total, and then go down each data service and figure out what percentage of the overall CPU hours. And that's how I do the calculation. So I just wanted to show people that at the very bottom, there's an export there. So it can kind of do that.
Oh, that was really great. I know I learned something.
Great.
Okay. So we are going to talk about, now that we've identified some cost savings and we're looking at the data services and the costs there, we're going to start identifying some components that would benefit from some optimization. So we're going to optimize pipelines. So to start, kind of a starting point that I like to look at whenever I'm looking for prioritizing what data flows to actually optimize, I look at the data products that have SLAs in place. So the way that you would manage that is you would look for the write connector or the transform before the data feed and identify that that's the output of the product that you have, and then start looking from the upstream and looking at that whole data flow to see where you can optimize. That's really helpful for, especially if you are missing your SLAs, to really do a deep dive and figure out how you can optimize that code. Now, if you do not have any SLAs in place and you're having a hard time kind of managing that, I really suggest that you go to the next session. That's with Michael and Alex. They're going to be unlocking business value with data products. They're going to talk about how you can actually start tracking your SLAs and identifying pipelines and the business that uses it. That's just a quick little plug there.
That looks like a great presentation coming up.
I think it's going to be definitely going to be wonderful. So then the next thing that I'd start looking at is the business critical data flows. So if you don't have an SLA, or maybe there isn't technically an SLA on a data product that's being used by the CEO, could be a dashboard that they like a lot and that they go in randomly, and every once in a while there's a failure and you don't know it until you get an email about it. So I would definitely be looking at those next for prioritizing.
Yeah, you know what, Tessa, one of the things I've seen is customers have a combination of both pipelines that have SLAs and ones that don't. And I think that becomes a little bit of an issue, right? Because those ones that don't, depending on when you put those in there, could impact the SLA ones, right? So I would recommend from a personal perspective is if they're, you might want to track like these ones have SLAs, these one have internal SLAs, right? So if you miss it by a little bit, it's not a big deal, but having SLAs in general, just so you can manage your pipeline and then know, okay, if I have these, where do I fit this next one in? Oh, this is going to impact a non, business SLA, but an internal SLA, that's okay. But just something to think about when companies look at that as an approach. They might want to create internal ones just to manage the flows as well.
That's a great point. So really, like anything that's highly visible to the company, you want to be able to identify that as an internal SLA. Yeah, I like that. Really great point. Next, I'd look for for any pipelines where there's looking at the frequency. So if data is loading several times a day, every 5 minutes, anything like that, I'd start identifying those pipelines. They have a risk for any kind of failure. You know, they're running more. You want to make sure you optimize that code there. And the fact that they're running more means that you're processing more data. And then, of course, last but not least, size. Looking at the pipelines that are processing large amounts of data, optimizing those is a great place to start saving on some cost there. All right, so next I'm going to start showing ways to find some components, find your components within a data flow that need to be optimized or are candidates for being optimized. I'm going to show you sort of how to look at that from the job usage, and then go into the timeline to look for anything that might have some competing priorities, and then finally just show you really quickly the SDK. And then we'll talk a little bit more about timeline. Okay. All right, so this looks familiar. Alex was just here. So for job usage, really great thing that I like to use is the sunburst. So when I come in here, I can actually see what is happening on Ascend right now. So I'm going to move it back to the vCPU hours. And as you can see, we have some demo data services that are going here. Yeah. So here in this middle circle, that's going to be all of your data services. And then the second outline circle is your data flow names. And then these go down to your components. So definitely we are working on some Summit training. If I click in here, I can see the data pipeline. I can see these a little better. I could tell that this is what's taking up most of my work. And just like how Alex had shown before with the table, you have the table here as well. And you can definitely export it if you like to look a little deeper.
Yeah, this sunburst is awesome. It's like not many people know about it. It's a great feature everybody should be using.
Oh yeah, I love it. So easy to work with. And you can just kind of drill in and drill out. Yeah. It's awesome. Yeah. Yeah. Awesome tool. All right, moving into the timeline. So we are looking at this from the level of the data service. It looks like a bunch of really tiny lines. So what I'm going to do is sort of drill into a specific time that looks like it has a lot of activity. And you can do that just by like dragging these together. You can start seeing, you know, what's happening here. And you can identify not only components or data services, in this case, that are running at the same time, but you can look for ones that are taking a little longer than others. So you can kind of see that this one takes a little longer than the Summit ones that had been running. So this is by data service though. I want to kind of break this down. We're going to look at just one data service, and then we're going to look at just one data flow based on what we saw from the sunburst of something that's running pretty heavily. And I'm going to change the grouping to the component level. And now I can identify components that are not only running at the same time, overlapping, that could have some competing priorities, but I can also identify ones that are long running. So these would be some good components to start looking at to see if there could be some optimization there. So the last thing I want to show you as far as looking for ways that you can identify components is using the SDK. So using the SDK, you can write really simple Python code here just to kind of be able to run through and pull in, you know, dates if you want to see the dates for each of these when they started and they ended. The SDK actually has access to all of the partition data. It can show you the duration, the bytes, all kinds of great information. So I definitely encourage you to check out the SDK for that. Now, we want to talk a little bit about prioritization. So I mentioned it really briefly whenever we were in the timeline setting. Whenever you had components that were running at the same time. So we do have the ability for you to determine which component has priority over the other components. You can do that at the read connector level, at the write connector level, and then at the transform level that creates the data feed. So when you're looking to meet those SLAs, you have a bunch of different data flows that are running. If you are able to identify the transformation before the data feed or the write connector that is providing that data product, you can set that at that level. Now, some people, they might need to set it at the read connector level. It does go upstream. So if you were to create the priority at the read connector, maybe you want a job just to kick off before the other read connectors in your data service or in your Ascend platform, you can do that. Another way, though, when talking about data products, would be to set your priority at that write connector or the transform before the data feed, because it will actually populate the priority upstream, which means that it will put priority on all of the components that feed into this write connector.
I have a question for you, Tessa. So sorry to break your flow here. So this is interesting. So customers, I think, struggle with this from the standpoint of they may have a transform that has a setting that no one knows it was like a higher or lower number. I forget which way it goes, but that could impact that. How do people manage that? Is there like some script they can run to pull the priorities together or something like that? Do you have any insights into that of what you've done before?
Yeah, I believe you could check it using the SDK because that'll have all of the component settings as well.
Okay.
Yeah, it's really helpful.
So they could do that. Okay, perfect.
Yeah, definitely. And with the priority, I'm glad you mentioned, I don't know if it's higher or lower because I did not tell anybody what that is. So yeah, priority 1 is lower than priority 100. So you want it to really happen, put 1,000, like it's the highest, right? The higher the number, the higher priority. I'm really glad you mentioned that.
Yeah.
All right. So we've identified that there are some components that are candidates for making some optimization changes, maybe some refactoring. What are some SQL or PySpark best practices? I'm going to start with SQL. I do want to preface this with the fact that I'm just talking about SQL in general transform logic. I'm not talking about in your database making changes to indexes or clustering or partitioning, anything like that, just the SQL queries. I would recommend that you use Windows functions. You want to do that instead of doing a self join and instead of doing a cross join. It'll definitely make your query run faster. If you have, let's say, a larger table and you're joining it to a much smaller table and you know that that join is going to cause data to be filtered out of the larger table, if you can filter it out before the join and create some balance in that join, it'll definitely help your query. Avoid using select distinct if you can. This subject kind of has come up for me before. I have noticed that in working in pipelines and looking to optimize code, I have found that a lot of times we're going to maybe assume that there could be duplicates, and so everybody puts select distinct. It does affect your performance. So knowing your source system and really understanding how that data is populated can help you to determine whether it's necessary. And if it is necessary, maybe try using a Windows function, see what works better. Definitely look for a feature like explain in your query editor, whatever database you're using. The explain, the query editor is going to be able to tell you what's happening when you run that query on that system. So look for it there. With PySpark, this is going to sound a little redundant because it's very similar to my SQL best practices. So you want to avoid shuffling. And how do you do that? Shuffling happens when you're joining, you're doing group by, you're using distinct or coalesce. An example is going to be if you're looking for the max of a field, instead of doing that and grouping by and aggregating and joining back to the table, doing a self join, use a Windows function. It'll definitely speed up the results. It also takes up less resources. Recently working with a customer, we made those changes to their Spark, their PySpark scripts, and it decreased the time and resources by almost half. So that's pretty, I mean, you're not going to get that every time, but that was pretty impressive. I was really excited about it. Use broadcast hash joins whenever you're joining to a smaller data set. So what happens in Spark is if you are doing a join, you're going to do that shuffle, right? But if your data set that you're joining to is really small, you can broadcast that to all of the executors so that there isn't a shuffle. So that's a really good little best practice. All right, so you can also optimize your pipelines using partition strategy. I highly recommend both of these sessions. Yesterday, Cheyenne did an amazing job on Partitioning 101. If you haven't seen it, check out the video. And tomorrow he's going to be doing an advanced training on partitioning in Partitioning 201. He's going to talk about partition unions, partition filtering. It's an awesome subject.
And one of the key things about that, talking to Cheyenne, is that's one of the biggest questions volume-wise that we get in support, because people have it set up a certain way and it's reprocessing everything because they put everything in a single partition and don't understand the strategy. And it's literally throwing money out the window if you don't know how the partitioning strategies go and how to use those to your advantage.
Yeah, and once you learn it, I mean, it's an awesome way to work with Ascend.